Then I check the number of the pages in each chapter. For example, this number is pages of each chapter. For example, introduction uses 18 pages, and atomic structure uses 50. And then following the atomic structure, 54, 35, 28, 48, 35, 46, 59, 59, 59. Until this 59 application process metal structure until the chapter 11. This is metal. And next is 43 and something are ceramics. And for polymer is 2 chapters, 54 or something. And the composite material has only 47 pages. There is 4 big materials: metal, ceramic, polymer, and composite. In the material science textbook, metal occupied a very large portion, and the next ceramic, polymer, and the composite has only 47 pages. And after that, corrosion, electrical, thermal, magnetic, optical properties. And here, this is a detail of the composite chapter, chapter 16. So, introduction, particle reinforced composite. Next is fiber reinforced composite, fiber length, fiber orientation, and concentration. Concentration means the volume of the fiber in the composite. So, chapter 16, composites consist of the particle reinforced and fiber reinforced and structural composite, plus nanocomposite in this textbook. So these are structural composites and nanocomposite at the end of this chapter. So chapter 16, particle, fiber, structure, plus nanocomposite material. So shall we go into the introduction part? So by read this introduction part, so we can understand the attitude of the material science. So this is the first page of the introduction. Introduction part is divided into these 7 chapters: historical perspective and material science and engineering. Why study material science and engineering? So here, a very good example: Liberty ship failures, and the classification of the materials and advanced materials and modern material needs, and finally, processing, structure, properties, performance, correlation. Materials are probably more deep-seated in our culture than most of us realize. Material is very important in our life. So that means the Cambridge University thinks material science is a natural science that is equivalent to the mathematics or something. And transportation, housing, clothing, communication, recreation, and food product production influenced on the degree of the another by materials. Historically, the development and advancement of society have been intimately tied to the member ability to produce and manipulate material to fill their needs. In fact, civilizations have been designed by the level of their material development. So many years ago, we say the Stone Age. After that, Bronze Age. After that, Iron Age. So when we think about the civilization development, we use a materials name, stone, bronze, and iron. That means materials are very close to our life. So material has a very decided history. The early human had access only a very limited number of the material. Those are stone, wood, clay, skin, and so on. With the time, they discovered that techniques and new materials include the pottery and various metals. Metals appear here. Furthermore, it was discovered by the properties of the material could be altered by the heat treatment. So the people understand that heat treatment is very effective to the metal or something. And also by the addition of the other substances. So the two materials mix. So that is an important attitude. And at this point, material utilization was totally a selection process. For this purpose, what kind of the material do we use? That is a selection process. Involves the deciding from the given rather limited set of the material. The one of the best suited of the application of the virtual its characteristics. And then next is the structural element materials and their properties. And then this knowledge acquired over approximately the past only 100 years. So thousands of different materials have evolved in the rather specialized characteristics. And that is metal, plastic, glasses, and fibers. So gradually, we can have various kinds of the material system and various kinds of the different system. For example, automobiles would not have been possible without the availability of the inexpensive steel or some other comparative substitute. So when we think about the automobile, very inexpensive steel is very important role. So therefore, car or automobile development depends on the material development. So therefore, I can say that material is very close to our society. And next is material science engineering. So in this chapter, I tried to explain the definition of the material science and engineering. Sometimes it is used to subdivide this discipline of the material science and engineering into material science and materials engineering. So we can divide it into two parts. Structural property correlation. Strictly speaking, material science involves investigating the relationship that exists between the structures, properties of materials. Material structure, material properties. These two categories should be studied in the material science. The first sentence explains the material science, structure and property. In contrast, materials engineering involves, on the basis of these structure property correlation, designing or engineering the structure of a material to produce the predetermined set of the properties. After we understand the structure and properties, we try to design the engineering structure something. That is a materials engineering. From the function perspective, the role of the material scientist is to develop or synthesize the new material, whereas material engineers develop the techniques for the processing material. Material science make a new material. Materials engineers developing a new processing method. And then next point is that yellow part, microscopic part and macroscopic part. So as I mentioned before, from the atomic to the crystal and the solid metal, so on, from the microscopic to the macroscopic. So this change from the micro to macro is very important in the material science and engineering. So when we observe the materials macroscopically or macroscopically, so that we need both scope. We need both standing points, micro to macro. Properties is the material tried in terms of the kind of the magnitude of response of the specific imposed stimulus. So that when we apply for example, apply the load to the material elongate and finally fracture something. So that response we should understand. From here until here, we understand the structure of the materials and the properties of material. And next is how to respond the materials to the outer stimulus. So the 6 different categories, that means 6 different stimulus. Mechanical, electrical, thermal, magnetical, optical, and degradation. So these keywords are very important from the stimulus viewpoint. Mechanical, electrical, thermal, magnetic, optical, and degradation. 6 different categories. Mechanical properties related to the deformation to the applied load or force. That is, you understand. And the electrical conductivity are the electric constant. The stimulus is an electric field. and the conductivity. Magnetic properties demonstrate the response of the materials of the application of magnetic field. Optical properties. Stimulus is electromagnetic or light radiation, and refraction, reflectivity, and optical properties. And finally is degradation related to the chemical reactivity of the materials. So the degradation means very, very close to the long time usage of the material.